what's up, Polyhackers? Woo! All right, everyone, give it up for Alex with his introduction to Go.
Thank you. Is it audible? Okay, yeah, I can hear myself. Perfect. Let me know if any of the slides are illegible because the colors are a bit off, I think. But it should be good. It's pretty contrast. So today I'm going to talk to you about Go and why I think it's one of the best languages to learn this year and forever more in the future. So let's start. So first we'll cover about Go, then why you should be learning Go, then some projects to check out, some like quick shout outs to projects. Then we'll touch a bit of syntax, and I think that part, because this talk was earlier, like a much longer talk, I think I'll have to shorten the syntax part a bit. So we'll cover as much as we can. And in the end, I'll give some recommendations on where to go from there, like how to start learning Go, the books, the courses, and everything. So let's go with this section first. So Go was created at Google. For the first 2 years, it was like a closed source, and then it was released in 2009. The creators include Rob Pike, who is probably the kind of like the mastermind behind it. He was working on some of the other projects we'll see that led to the development of Go. I think it's called CSP is the one that he was behind, and Plan 9 is another operating system he was developing. And these people are also responsible for the language C, B for Unix, for Unicode. So there's some good kind of roots from which Go stems. And you'll see that as we go through. So some of the Go values are it's thoughtful, so it's simple, definitely. That's one of its advantages. And it's super fast, which is not listed here because it's values, it's not like characteristics. But so here is a photo I made from like a textbook I own. So here we can see, I don't know if you can see the cursor, but this is the CSP I was talking about, which kind of led through Rob Pike. He kept developing it, and CSP stands for Communicating Sequential Processes, and it's part, like this is how Go got its concurrency, the channels, the Go routines and everything, and it got its, so it has packages, right, and it got them from Pascal, kind of through all of these developments. And Go is similar to C. If you have ever worked with C, it has certain things that make it easier to use and harder to make weird bugs with, I would say, which leads to it being still fast. It's not as fast as C, but it's comparable. But you don't have to worry about, the biggest thing I think you don't have to worry about as you come from C or C++ is the memory. You don't have to do your own garbage collection. It's automatically done for you. It's strongly typed. It's compiled. Concurrency is its core feature, as we'll see in some examples. So it takes a bit of a different approach for object-orientedness, I would say. So there's no classes. There are structs, which can have methods on them, and there's interfaces. So your structure might implement a certain interface or your type that you create, and if it implements all of the functions that are described in that interface, it is treated as the same thing. Basically, if it quacks like a duck, it's a duck, and things like that. It just assumes, you don't have to explicitly say that, oh, this class extends this class, that extends that class. It's done automatically by Go for you. So why learn Go? This is some of the quick stuff we're going to run through. This is the interest to Golang over time. This is the only, I guess, dated slide that I have, just because I don't have a more recent one. So Go here is one of the 9th out of the 15 most popular languages on GitHub. This is newer. So this is this year, the latest Stack Overflow survey, and Go is, I think, 5th year by most loved, and 3rd by most wanted, so wanted by employers. Here, HackerRank, Go is the language that people really want to learn this year, it seems. And JetBrains, who make all these like IDEs like Golang or what the other one, like RubyMine, PHP Storm, WebStorm, PHP something, WebStorm. They also made their own survey, and Go was the most promising. This is some of the companies that use Go, and the list is really growing. On the right, you can see some of the companies in Toronto or Canada, also Hootsuite is like both, that are using Go. And yeah, it's a pretty good list. Some really big names in there, and we'll see why eventually in some other slides. So yeah, it's super fast, as I said. And what also here we'll, I guess, focus on this one, and that Moore's law is failing. So basically, the speed or the frequency of the CPU core cannot just continue to rise forever, and what we end up with is like hexacore and more core processors. And Go is really the language you want to work with to take advantage of the multiple cores, because every Go routine that you kind of spawn, it can be utilized on a separate core, which makes your programs way more performant than in some other languages that cannot do that. So also, no, that's fine. This is the new slide that I kind of wanted to bring in, is just why some of the employers are adopting it right now, and how you can make the case for your company to bring Go as part of your stack, or maybe eventually the stack that you use on the back end. Depends on the kind of the use case that you have in your company. So easy to maintain the code because of the Go FMT. So Go has a certain tool called Go FMT, which formats your code in a certain very opinionated way. And the saying goes that nobody likes their code formatted by FMT, but everybody likes some other people's code to be formatted by it, because you know what to expect. It's easy to look at the other project's code and understand it. There's no weird inheritances, so Go also doesn't have inheritance, like I mentioned before, which helps to a new developer who is coming into a project that already exists to kind of get a feel of what the project is like. And that kind of also goes into that some companies would say, even on their ads, like, oh, we're doing Go, but you don't have to necessarily know it, we'll teach you. And that's because it's one of those languages that's easy to teach for a person who, if you're done work in any other language already, they'll just, you'll pick it up in like a month or two. Lower infrastructure costs is that you can save up on those servers, because Go can handle those requests faster. And it's cross-platform, so you can basically, you have the same Go code base, and you can compile your code to run on Linux, on Windows, whatever. ARM, I think, is another part, like the Raspberry Pi and all of those. And it's easy to deploy. You have your binary, you can just drop it in any server you want, and it's gonna work. And for developers, it's just pleasant to write code in, super fast, it's gaining popularity. So this year, probably the one where you want to start learning it. It supports Unicode by default. And here we can see, just talking again how it's cross-platform. And it's inspired the creation of projects like Docker, Kubernetes. It's used in Ethereum as well. And that we mentioned already. So let's just go to the project we can check out. This is a framework you can use if you want to do any sort of hardware projects like Raspberry Pi, Arduino, BBC. They have some hardware of their own, which I forget. Then the next one is Hugo. This is similar to if you ever used Gatsby.js. This is a static site generator that's insanely fast. Once you create your website, it just works super fast. So next one is Go Buffalo. This is similar to, I guess, like I could compare it to Rails. So it's a full-blown framework with like a backend if you want, and it's very customizable. They have some examples. For example, you can use it with Vue.js if that's something you do. You could have a backend powered by Buffalo. They have like their own ORM of choice and everything, the router, they have it all figured out. Go Ethereum is just another example. I don't know much about it, but I've noticed it's one of the, like, It's like 24,000 stars compared to other ones. Yeah, it was like the more popular one. And I guess one of the points is also the speed of it. So Kubernetes is container orchestration, which I also don't know too much about. It exists. And for microservices, there's a framework called GoKit, which you can use. So there's a variety of use cases for you to use Go. And you can start with some side projects or working on whatever. It could be like a small command line tool. They have a really good flag package that you can use for that purpose as well. Super fast. If you like, one of the examples I use that for, let's say you have a backend and you don't have an admin for it, and you want like a script to create admins for your website or whatever. You can whip it up really fast with Go. So let's go to the syntax. So if you're coming from a web I would say not statically typed language, you're going to have some surprises, but it's not going to be too difficult to learn. This is just some quirky things I've collected. There's going to be more fundamental things in the future, but just to get it out of the way, there's no semicolons, almost none. No semicolons at all, almost no brackets, and everything should go through the GoFMT tool. That's kind of like you just take it and run with it, similar to, I guess, like how Python has its own, PEP or whatever, I forget, or pip. You can use double quotes for strings, not single quotes. That's for people who come from JavaScript. But you're going to learn that pretty fast. Compiler will just yell at you for doing that. Anything named with a capital letter is exported. And here's one of the nice things how Go manages certain complexities without being too verbose, as opposed to export this method publicly. Anything that's named with a capital letter automatically gets exported, and that's how you can save up on some of those letters. Unused variables are not allowed, so that is basically a good thing for large projects as code tends to grow. Sometimes you get a project that has so many different dependencies, and in certain other languages that don't have this constraint, you as a developer are sometimes you're afraid to remove certain things because you don't know what it's gonna cause. And here it kind of makes you do it as you develop your app, so you're not accumulating things as you go. There's also a Go doc, so this is automatically generated. If you follow the GoFMT rules, if you comment your code with the command Go doc, you can automatically create a documentation for your package or whatever you're developing. And you can see that for anything in the Go standard library, all the docs are created with the Go doc command. And it's a pretty it's not a verbose language, so it only has 25 keywords. These are these keywords. These are the numeric types, the base types, I would say, that you care about. We'll go through that later on, just to okay, perfect. So this is the syntax of it, and this is the Hello World code, which I guess is tradition to start with it. So FMT package deals with formatting and printing to certain, either to standard out or just if you want to create a string and run it through some processing, you use FMT package. And anything that you create, if it's a package main, Go knows that it's going to be an executable. So when you go run or go build, it would create a binary executable out of it. If you're using any other libraries as dependencies that just help you create your app, they would be called package crypto or package whatever, and you can use them as well. But in order to have an executable, you start with a package main. And imports are also managed for you automatically. There's a Go imports tool as well that you can use. You can either do it on your own, but why would you? It's automatic. So variables. Here in Go, you can either specify a type right away, or you can short declare, which we'll see in the next slide. And if you short declare a variable, like this. In the middle, you see the f variable is using a short declaration. That's the most common way to declare a variable. And Go will kind of guess based on the value that you provide what the type of this variable is, and that's not going to change because it's obviously a statically typed language, but it's smart enough to understand what you want. There's also a const, which is used more, I would say, more rarely. And another really cool part about Go is that it's when you declare a variable like this on top and you don't provide a value for it right away, you don't initialize it. It will be initialized automatically to a 0 value for that type. So for int it's a 0, for a string it's an empty string, but expect that there's gonna be something. There's no undefined or nothing like that in Go. For loops you have only the for keyword, and you can construct with it any type of loop that you want. For example, this is a while loop. I think based on what I did before. This is the for loop, like you would use in like JavaScript. This is an infinite loop, if you want. You can break out of it if you want, anytime, with the break keyword. And notice no brackets here, no semicolons, as I said before. This is simple if-else statement. There's a switch, and as opposed to something like JavaScript, the fall through is explicit. So most of the time you don't have to do like the break like you have to do in JavaScript. That's my personal gripe with it. Here is a different type of switch that's available that allows you to switch on a type of a variable, which sometimes also is useful. And this was new for me as someone who comes from I don't have any background, so I am self-taught and I've learned JavaScript on my own. And with JavaScript, there's no pointers or anything, so that was a new concept to me. At first, it was a bit hard to understand, but then I kind of got it. And it's pretty easy if you're coming from a statically typed language, I would say, or something like C++, where pointer is just a pointer to the memory address for that value that you're looking for. And because in Go, when you are using any type of function, it's always a copy or like passed by value. So if you're, let's say we have a huge struct, like a user struct that comes back from a server, it gets like unmarshaled from the JSON, whatever. You have a huge struct that you need to do something with. And then you would use a pointer if that struct would have any methods, because if you don't, you end up creating a copy every time you use any sort of function. It creates a copy of that whole struct. So that's, I guess, the main reason why you would want to use a struct, and then there's some other ones, to my understanding, you know. Go also takes a different approach to error handling as some of the other languages do, and what I like about it as well, that it keeps errors, like it thinks of errors, I would say, as like a part of life. So you handle them not as exceptions, at least in the current implementation of Go, until they do any sort of like new things that are coming up. We don't know yet what's gonna be there, but for now, errors are a part of life, and we expect them to happen. And that's why often, like here, we're expecting this function to return multiple like values to us. One of the values is error, and we kind of deal with it right away, and we forget about it later on. We don't have to be guessing what happened. Like if something went wrong, we'll know right away. And there's also a defer statement, which I've read somewhere that it's new to Go. There's probably some other structures in other languages that are similar to it. But what it does is it defers the execution of this statement of closing the body until the function. Let's say this whole thing was a function. Until that's done, this will not run, and only in the very end it would close the body. It's done so that if you have a huge function, or not even a huge, but like long enough, like 20 lines, that you don't forget to close the body, and you don't cause a memory leak or whatever. Let's go further. So these are functions, and this thing on top is a function signature. So it would contain a any parameters or arguments that it's taking, and what it returns. As we'll also see in the future with the structs, how it can have a receiver type. But for now, we just make a note that you have to specify what the function takes, what it returns, the types, everything. Okay, so this is arrays, and arrays are different a little bit than what we're used to in the web world in Go, because they're not really what you think of arrays as. Let's say in JavaScript, arrays can be modified. In Go, they cannot. This is like the base structure behind what slices is another structure in Go that I would say it not reminds me. It's basically what you think of an array in JavaScript is a slice. What's behind it, though, is the actual data represented in memory, and that's the array. So with arrays, the 3 and the int are both part of its type. So it's an array of 3 ints, and it cannot be adjusted. It cannot become an array of 4 ints. It is what it is. So it's, I would say, rarely used. It has its uses, but mostly it's used as a thing that's behind the slice. And for slice, you don't have to specify the number of elements it takes. It readjusts itself as you would expect an array to do in other languages. And this is the way you add to a slice. In this case, it was a slice of 3. And then we add the 4th element. It holds 4. And basically, the slice has behind it, like slice is a pointer to whatever is going on in the memory, where this is like an array of 4 elements. So it starts off when we do like an array literal here, or I guess a slice literal. Behind in the memory, behind the scenes, is an array of 4 elements with the 3 kind of filled in, and we're putting the 4th one in here, so it won't readjust the array behind. However, if we were to put the 5th one in, it would create a different, it would scratch the copy that it has of the array behind it. It would create a new array of 8 elements, so it doubles it. And then it would fill the 5 slots in there, and it just keeps doing that without you even knowing, which is great. Because when you work with slices in functions, you don't have to keep doing the pointers, because it's already kind of a pointer. And it deals with the memory on its own. Then there's maps, which I guess is similar to any other language. So this is how you get something from a map. This is how you set something in a map, delete. However, what makes it interesting also is that, you know how I mentioned that in Go, any sort of variable is initialized to its 0 value. So in this case, if we were to have it like a map of string to string, and we query some sort of string that doesn't exist, it would give us an empty string. But how do we know if it actually exists on the map and it's an empty string in itself, or if it's just a property that doesn't exist, or like a field that is not in the map? So there's a special, I don't know if I have it here. Yeah, there's a special construct called, I guess I call it the OK construct, which allows you to give a second variable. And basically, if OK is true, it means that even if it's an empty string in our case, that field actually exists in the map, and that's how you check it. And you can't just define a map; you have to initialize it right away with a make keyword, and then it makes it for you. So here are the structs, which is a typed key value store, I guess, or like a field structure in which every field has a certain type. And on this, on any struct that you define on that type, you can also give it some methods. And that's how object-orientedness is done in Go. Here on the bottom is where we do a struct literal. And we can specify every field, or we can do a quick declaration. But in this case, we have to obviously follow the sequence of the fields that are defined as struct type. I would recommend going for the second one, just to be sure. This is how you define a method on a struct. So here, see, this is like kind of like a receptacle, whatever recepts our our method. And it's a very simple one, just like say name, and just spits out in a random string that has a field that it takes from the struct that is here in the, I forget what it's called, it's like a reception something. And basically we refer to our struct within this function as a P, and we can do all sorts of things with it. But it won't create a separate copy of it, it'll just keep working with the same one. So if you need the function or the method to modify the existing struct, you obviously have to use a pointer. If you don't care about it, you can get away without using the pointer. But just make sure that your struct is not too big for that. Go routines are pretty easy to create, and this is how the concurrency is done. You just use the go keyword, and this is like a function that we just run right away, like a IIFE in JavaScript, similar. So it keeps running in its like separate thread. And here's an example, just a quick example of channels. And we'll go through some stuff super quickly because I think we're going to run out of time pretty soon. But this is where we make a channel. Also see the use of the same keyword make as we use for the maps. We declare it, initialize it right away. And then we create a go routine here, which just sends a string ping to the messages channel. And here we're just awaiting for that message and print it out right away. So that's like the most trivial example I could make of the channels. Some helpful structures. This is similar to like a for each in JavaScript, or like just going through every item within a certain structure, like a map or array, or sorry, like a slice, maybe array as well. This is string interpolation, I think. Yep. And there's this is called a print verb. So there's a bunch of those, and if you do like a plus v or v plus, it will, and you run it through a struct, it will also give you like every name of the field in a struct. So it's pretty powerful once you know more of those print verbs. So this part was just like if you want to get set up with Go, some exercises, which I'll share that presentation later on, so you can grab some of the simple exercises in there. But I want to go to the, okay, perfect. So these are the resources on how to get like started with Go. This is one of the most, I guess, in-depth books about it. You could also start with this one, which is like, it's like double as thin, and it's more practical. It's like, I guess it's easier to get through. So you could start with the Go in action and then graduate kind of the Go programming language one. There are courses on Udemy, and there's some courses by John Calhoun that I would recommend. So this is probably the first one I would recommend to start with because it's relatively short. And compared with the Todd McLeod one, which is like it also attempts to teach you how to program as well. So if you're already a developer, I would go with the Writer's course for sure. And he has a good way of explaining things. There's also a tour of Go that's available on the Go website, which is like one of the first steps you could take. It's sometimes a little bit intimidating for, like, if you have never worked with a statically typed language. For me, I guess it was in the beginning. So I just went directly to the Udemy courses. But there is a track on Go on exercism.io, which I would highly recommend because it has like 100 exercises, but 18 of them are the main track. And on the main track, you get basically mentor feedback for every exercise that you do. Or if you struggle, you can also submit your solution, they'll help you. And that, I think, works best because it's kind of like someone is teaching you certain things about Go, as opposed to just like being on your own. And Go for Sizes is a free course, which it's not a course that you have to do from the beginning to end. It's more like very practical examples of things you might have to do in Go, like generating a PDF or reading JSON, marshalling, unmarshalling, and things like that. And it's completely free by this guy, John Calhoun. He also has 2 paid courses for Go, but they're a bit more expensive than like your Udemy stuff. So I would say if you can get your company to pay for it, do it. If not, it's fine. It's like 150, I think, or so. If you really want to learn Go, you can invest. And that's it, I think. Yep, that's it. Thank you. If you have any questions, I'm open to questions. Not super technical. Please. Perfect. Oh, okay.
So you said it has zero initialization for variables, right? But can you still get null pointer exceptions? Is there still nulls or nils?
There is a nil value, but I think let's say you've taken a struct and you initialize the struct to a 0 value. It's just going to be that every field in that struct is initialized to a 0 value for you. Yeah, that's what I would guess.
I got one other question. You're saying you want different operating systems, right? Is there like a Go VM then?
The Go VM?
It builds and executes those
Yeah. So it's just a binary. You drop it in your server and it just runs. Okay. It's just made for that. You have to specify the architecture of the server that you're using. If it's Linux, 64-bit, whatever, it's just gonna use that and it's just gonna run there. I think I might be wrong about thinking back about your first question. I think I might be wrong. Would it be nil? Yeah, but there is a nil value that you can also use. Yeah. Thank you.